Hello everyone, and welcome back to AI Tuesdays. My name is Erika, and I am the Program Manager at Microsoft Reactor Stockholm. Today, we are going to continue with the fifth episode of the AI and Machine Learning track in the Championing Azure Collection series. This series provides an introductory overview of Microsoft's AI and is perfect for those that are early in their developer career. In this session today, you will learn more about AI and machine learning on the Azure platform and how you can leverage these technologies in a responsible way to enhance your applications. But before I carry on, I just want to say a quick word about Microsoft Code of Conduct. We all come from different backgrounds, but we are all here to learn. So please be aware of each other and be welcoming and respectful. Thank you. Now, let me introduce to our speakers today, Alan Smith. Alan is a familiar face in this series by now, as he has hosted many sessions already. Alan is an Azure mastermind, an MVP, a software engineer, a mentor, evangelist, and so much more. He has once been also recognized as one of the top 10 developers in Sweden. In this very developer-focused session, Alan will start with the basics of neural networks and explain how they can be trained to clarify images. He will then move on to more complex convolutional neural networks, or CNNs, and explain the details of object detection. This session is going to run for about 40-45 minutes, and we have time for questions at the end. I have now spoken enough, so let's bring you here, Alan. Hello.
Hi, good evening.
Hey, good evening. Thank you so much. Oh, I need to add you need to share your screen so I can have your picture here with us.
Yeah.
But thank you. In the meantime, just let me say a big thank you again for being here with us today. It's super great to have you. Now there you are.
Yeah, great.
Hey. Yes. So yeah, thank you so much for being here again today. It's super appreciated from us, the Reactor team, and as well as our audience. So yeah, I'm just gonna put myself in the background, but I will be here if I'm needed. Okay.
Great, thank you for that. I'm going to try and keep the slides to a minimum for this presentation, and starting out with talking about a bit about the Azure Custom Vision service. When I first started working with this service, I just found it so easy and intuitive to use. And around about the time, this was before all this COVID craziness, my daughter was going to a Coder Dojo, which was hosted in Stockholm. As you can see on the screen, it's kids. I think their age limits was sort of between 9 and 15 and 16. And we just basically went on a Saturday morning. There was various companies that were very gracious and lent us their office and basically bought lots of sweets and biscuits and drinks for us. And we could just basically teach kids the basics of programming. So I basically suggested the idea of using the Custom Vision service. You can see we've got Harry Potter and Hermione Granger and Ron Weasley. And I basically wrote a really detailed lab on how you can basically use about 15 images of these three characters. You can then use the Azure Custom Vision service to train a model to do face recognition for the Harry Potter characters. Of course, as soon as the kids got the lab instructions, they just threw them away and just basically went in and built and trained the actual models. And it was great to see, the next generation of developers. It's going to be these kids who are growing up and leveraging the AI technologies that we're currently, struggling to understand ourselves. And it's it's going to be good to be able to see what that future generation can do. So I'll talk a bit about the service and what type of things you can do with the service, what type of things maybe limitations on the service when you need to start programming in Python and doing lots of stuff with neural networks. Starting out with image classification, you can see that's a cat, and then that's a dog, and that's a dog. But think about the complexities of writing a computer program that can actually give it an image as an input, and it's going to output cat or it's going to output dog. It's going to be really, really hard to be able to do that. Object detection is basically focusing on identifying objects with an image. So here the entire image is a cat or the entire image is a dog. But here there's a dog and a cat in the image. So the object detection will basically locate an object within an image, and it will give you a bounding box around that particular object. And depending on the actual scenarios, we're going to choose to use a classification model or an object detection model. So that's the two main models that are supported in Custom Vision. What you can't do in Custom Vision models, I should have actually put this as not Custom Vision models. So these are currently not yet available in Custom Vision. It will be nice to see them available soon. And the first one is semantic segmentation. Now, with COVID, we're all very used to semantic segmentation. I'm actually using a green screen behind me. But if you haven't got a green screen and you're working in Teams or whatever you use to present with, you can basically set your background to blur, even though you haven't got a green screen. You can also put another background in. And that's known as semantic segmentation. It uses an AI model to identify the pixels that are basically the person, and then the background pixels are going to be classified as background. And you can just basically replace the background pictures with something else. And then you see if somebody picks up a pen and they've got one of these blurred backgrounds on, it gets a bit confused over whether the pen belongs to the person or whether the pen is part of the background. But that's basically an AI model that's doing this semantic segmentation. You can see here it's used to identify the building, the trees, the sky, various vehicles, and the road in self-driving systems. Another thing you can do with images is regression. There was a website that Microsoft provided a couple of years ago where you could upload a photo and it would estimate a person's age. So what we're doing here is that we're doing the face identification, we're doing the object detection, but then from the actual face, we're getting a numerical value out based on that face. And the numerical value is getting, what is the actual person's age based on that particular image. And this is known as a regression problem, in that we're getting, some kind of numerical value from the actual data that we are inputting. So I'm going to whiz through the theory of machine learning really, really quickly and just talk a bit about how image classification works. I'm going to try and get this thing. For some reason, this slide is appearing on a different monitor, so I'll just skip doing it in the actual presentation mode. But image classification, you've got some images you want to identify, maybe who's the Simpsons character. Now, learning the basics of this, you'll maybe start out with the Fashion MNIST dataset. And this is taken, I can't remember the name of the clothing company, but it's a clothing company website where they've taken all of these images, they've reduced them to a really low resolution, and they've turned them into grayscale. And there's basically 10 different classes in this data set. You can see those down here. So the idea here is, we've got an input. What output are we going to trigger? So we build a neural network that can basically take the inputs, and it can basically give a prediction on what the output is going to be. Starting out, it's not going to be accurate, but if we go through the training process and do our back propagation, eventually the neural network will basically learn based on those pixel values what is an ankle boot. Now, this is a very simplistic scenario. You can see that all of the images are basically of that particular image. They're nice and centered, and that it's not too complex, whereas something like this is much more complex. So we have to use a much more complex network, a convolutional neural network. Now, you can do this stuff using Python and PyTorch. It's good fun. You need a big GPU to run it, and there are specialized situations, I'll talk about those a bit later on, where you may want to build your own custom model using PyTorch. But using something like the Custom Vision service basically makes life very easy for being able to work with these types of models. So I've logged in, and you can basically go to customvision.ai and sign in. You'll need an Azure subscription to be able to create the resources, but then you can create projects in here. And you can see that I've got a number of projects present and running. So I'm just going to delete this dogs one, which is in the Forza. project, and I'm going to create a new project here. And I'm going to start out looking at image classifications. So I think we'll call this Simpsons. And I'll drop that on the Forza one. This is on the paid price tier. You can also get a free one, but because I'm doing demos, the paid one is going to be a bit faster. Now, what I need to specify is, am I doing classification or am I doing object detection? In the future, we may see semantic segmentation appearing here as an option, but now it just supports classification and detection. And I'm going to go for the Simpsons characters, and I'm going to do a classification project. And it's asking me, is it going to be a single tag per image or multiple tags per image? And I'm going to use single tags per image. And then we've got the actual models that we can use, the actual domains. So these are using networks that are kind of tuned towards specific scenarios, such as identifying food items or identifying products on shelves in a retail scenario, identifying landmarks and various things like that. And I'm going to just choose a general one for this one, and I'm going to create my project. And once I've created my project, I can start to add images to that project. So if I add images, I'm going to go down to my AI data file, into the images. And what I've downloaded is the Simpsons character data set, which is from a website called Kaggle. And you can just basically download this, and it's got various Simpsons characters, and it's got various different images of those characters. Now, some have more images than others. You can see this one's only got a few images, whereas somebody like Abraham Grandpa Simpson has a large number of images. And what we need to do when we're working with these data sets is we want to have a balanced data set. That means it's no good having 1,000 images of this character and then only sort of 8 or 9 images of this character. It's not going to help the model to be able to train. So what I'm going to do is to select a reasonable amount. I'll go for I'm not sure how many I'm selecting here, but there's a couple of rows of that character there, and this one was going to be, actually I'll do that again, and I'll remember to copy the name of the folder in here. This is going to be Abraham Grandpa Simpson. And we'll take those images there. I'll bring those in. I can just paste in the tag. And there's going to be 55 images of that character. And then we'll choose another character, add images. Let's go for Bart. And select a bunch of images of Bart. And copy the name for the tag name. So there's Bart Simpson. And let's go for 2 more, add images, and we'll go for Chief Wiggum. Why not? He should be distinctive because he's always wearing that hat, so hopefully it's going to be quite good at recognizing that one. I'll do that again. I'll remember to select the tag. Paste that in. And then finally, we will go for, who can we choose? Homer, of course, everybody's hero. Let's drop that in, and I'll copy the tag name. Okay, so now I've got the images loaded up. I do need, I will try and be a bit precise and get a balanced data set. I need 10 more images of Bart Simpson, so that should give us a nice balanced, or it was 11 more of Bart, so that should give us a nice balanced data set. So I'll take approximately 11 images there. Oh, I got that one right. Art Simpson. Oh, that wasn't too good. Let's try that again. Sorry about that. Let's delete those. Yeah, I'll just leave it at 44. I mean, it is a fairly balanced data set, but I'll get rid of those ones there so we don't have this kind of stray tag there. Actually, can I tag them as Bart Simpson? I probably can. Take away the Art Simpsons tag. Yeah, now I've got 55 of Bart Simpsons, and I can delete that tag because we don't have any instances. So now I've got my balanced data set, then I can train the model. Now, if you've done anything with machine learning or heard about machine learning, you'll basically understand that training a model takes a really, really long time. Sometimes it can take hours, sometimes it could be days, even weeks to train models really comprehensively. So obviously, our session is 45 minutes. I can't do the advanced training. Here I can select a training time of, say, 55 hours. That will basically keep training the model until it's optimized, and then it will stop. So this is kind of a maximum training time, but we can do quick training. Which usually just takes a couple of minutes. Now, it does depend on how the resources are being used within the particular Azure region that I'm selecting, but hopefully by the end of the session, we should have this model fully trained. So that's looking at the actual classification. Going back to my projects, most of the projects that I've been working with have been with classification. So I do this demo with fast cars, where we've got these different images, and what we can do is basically recognize the actual car based on the particular image. And you can see the actual accuracy and the statistics on that. I mean, if we want to, we can run a quick test on that. So what I want to do is to maybe Google for images of a Tesla Model S and just get an image for that. So Tesla Model S, and go to the images section, and we've got a bunch of images here. So let's take that one. Looks okay. That was from Wikipedia, so I'm probably allowed to use that. If I open the image in a new tab, that should give me just the URL to the image, and we should be able to go back here and just drop in the URL and see what it thinks. Invalid input size. The image is too large. Oh dear. It should be able to scale the image. That's a bit disappointing. Okay, so I'll try again. It was a pretty high resolution one. I don't know if that one's going to be any better. Yep, that looks okay. Open image in new tab. And back to the custom vision. You can see that's 93% certain either it is a Tesla Model S, only 3.6% certain it's a Lamborghini Aventador, which was the next choice. So you can actually test it using this. There is also an API that you can call. I'll see if I can demo that using a Logic app to be able to call that model a bit later on, because I do have a Logic app set up to be able to call it. One of the sessions I was doing, I was actually working with music genre classification, and I was building this custom model that was using music genres. But what I've done here is I've basically taken a data set which has a number of different styles of music. So you get all of these different music samples. I think there's 100 30-second clips of each music genre. What I've done is I've taken the actual spectrograms that are graphically generated from the actual music. So this is kind of a frequency against time. And if we look at blues, you can see what blues music looks like, the actual spectrograms for blues music, and you can kind of compare that with classical music. And this is an interesting scenario in that normally when you're looking at the custom vision services, as humans, it's very easy to tell what's a cat and what's a dog. However, here, it's really, really difficult. I don't know if any humans can actually detect the type of music just by looking at a particular spectrogram. There's maybe people who are that into, music production who can, I'd guess what the music would sound like based on the actual spectrogram. But for most humans, it's pretty difficult to do. But if we look at the performance of this model, it got the actual over average score of 83.9%. And here we can see the actual scores that it got, classifying those music samples just based on the spectrograms. That really impressed me of how accurate it was based on it's not really photographic image data, which the model is built to train. It's kind of other data that's been converted into an image, and then it's the image service is able to analyze it quite well, give quite a good job on that. So let's go back to Simpsons and see what's happening here, and look in performance, and see. You can see that it's still training. I'm just hoping that's going to be ready on time. But what I'm also going to do is to show you a bit about how we can work with the object detection using this service. It takes quite a bit longer to work with an object detection database. And what I'm going to do is to use the Harry Potter examples. So I'll just do it as Harry Potter, and I'll use the Forza one again, but this time I'm going to do object detection, and I'm going to choose the general option here. So here you've got things for, recognizing products on shelves. This is used a lot in the retail industry. Somebody can go around with a mobile phone, mobile device, and they can basically scan the projects, the products on shelves, and be able to, do counts and inventory counts and things like that. We've also got logo detection, which is another useful scenario that we can use for being able to, detect logos, advertising logos, and so on. And I'm going to just choose this general option here, and I'm going to select create project. Now, for uploading the images on this, I have started creating a data set, and I'll show you how I do this. So what I've done in the Harry Potter, you can see that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 images, and I think the minimum is about 15 images. And I started doing this before the presentation started. What I've done is I've Googled for Harry, Ron, and Hermione, flipped it onto the image search, and then I've just gone through selecting various images that I can actually use in the actual training set here. So I can't remember if I did that one, but what I was just doing is just doing save image as, and dropping them down into the actual folder. And then for each of these, we just do save image as, and the next one. What I'm doing is just basically building up a suitable data set. Now, normally you'd kind of want these data sets to be in the thousands of images, but that's very challenging when we work with object detection. And you'll see this when I start actually training the model. So I think we've probably got enough to start uploading the images. Some of these may be corrupt or a bad format, so I want to make sure I've maybe got a couple of extra ones there. Okay, so what I'm going to do is just basically select all of these images and see how many of them we can bring in. You can see I'm not going to specify the tag when I upload the images, because I'm going to have to identify and basically draw boxes around all of these. Okay. So we've got 20 of these loaded up. We've also got this smart label feature, which will allow us to assist with the labeling process. So this is where things start to get a bit tedious. Here, I was just wondering, Erica, if you're listening, if you could just put the YouTube link in chat, so I can just see if there's any questions coming up. So here we've got to manually identify the actual, I'm not going to go for the whole characters, I'm just going to go for the faces, just do face recognition. I have to basically draw this box here and say this is Harry. I'll just keep it lowercase. And then this is going to be Hermione. And this is going to be Ron. And that image has now been tagged, so I can go to the next one. Now it does become a bit easier because I have actually and then that's going to be Harry, and this is going to be Ron. Next, and we go for Harry, Hermione, and Ron. Now imagine you got 10,000 images to classify. This is not going to be fun. It's going to take you a long time. So there's various ways that we've got and various tooling that's provided. And this is really in the Azure machine learning functionality, where you can basically have a team of people who are doing this. You can also outsource this to other regions and be able to get other services being able to tag. So you can also use AI in the tagging process. You can basically train a model that's going to be providing assistance with that. It may draw the boxes on and you may actually have to clarify. I think there's about 15 that we've got to get set up for this, and then we can actually train the model. The outputs of the model is going to be slightly different as well here, in that it's not just going to give us the percentage of the tags, it's going to give us all the bounding boxes. And this is something that the computer vision service provides us a lot of help with. I've actually done this using regular models, and instead of getting a nice generic list like you're used to in .NET, you basically get a list of floating point numbers, and you have to do all of these calculations to try and figure out where all the bounding boxes are, and it can be a bit challenging. I'm not sure how many I've got done now, so let's I'm going to try and get the minimum amounts to actually start the model training and then run through that training process. So this is going to be Ron, it's going to be Harry, and then we've got Hermione, and then sorry, Hermione, Harry, and Ron. I'm just going to see if this is going to be enough to actually start the model training. Obviously, it won't be too accurate. If I go to the tagged images, we've got 10 of each. Let's just see if it will allow me to train using the quick training. Oh yeah, we need 15, so I need to do 5 more. So I've got enough to do that. So let's do 5 more. So there's Hermione, Harry, and Ron. That was 1. Harry, Hermione, Ron. I think my accuracy is going down as I'm trying to increase the speed here. I think this is the last one. That's a pretty small one. Let's skip that one and go for that one. This kind of looks like it's been drawn instead of being an actual photograph, but I think it will still work. And let's just see if we're done. Yeah. Oh, we got 16 on. I missed one on Harry, but we'll go for that anyway, and just do the quick training on that model again. So hopefully, again, this is not going to take too long to train. I'm going to drop back to the projects and see if the other ones are ready. So if we go to Simpsons and to Performance, we can see that we do now have the trained model on that quick training option. I'm guessing it's maybe around 5 minutes, certainly less than 10 minutes that it took to train that particular model. We can also see the accuracy here saying 98%. Now, I'm kind of not too convinced that it's 100% in these 2 characters, because I've used so few images. If you're basically doing a multi-choice test and there's only 3 questions on the test, you may get 100% by chance. With there's 30 or 300 questions on the test, you can have a more accurate statistic on what your actual statistics are. So because there's so few images, it does tend to give sometimes an over estimate as to how accurate the model is going to be. However, we want to test this. So what I'm going to do for the quick test is, instead of querying for images on the internet, we can basically go to the AI data images folder, and we can go to the Simpsons data set. And I've been selecting images from the top. So if we go down and select one of Abraham Grandpa Simpson and open that, and You can see it has predicted 75% certainty that it is Abraham. And then let's browse local files and we'll go for Bart. Scroll down a bit and choose this one here. That will do. And then 78%, it's got that one right as Bart Simpson. And then we can go for, who else did we have? Chief Wiggum and Homer Simpson. So let's try those ones. So Chief Wiggum. Oh, I'd use that one. Yeah, so let's scroll down and choose that one. And it's got that one right. And then Homer. And then it's 97.4% certain. It only knows these characters though. So if we go in and we pick somebody who's not in the actual data set, it's not going to understand who that is. And here it's basically saying, well, it does kind of look like Bart, kind of looks like Abraham, Grandpa Simpson. So it's not really sure on that one there, but we could fairly easily add Lisa Simpson to the actual training set and then run the training for Lisa as well. Okay, so I'm going to go back and see if the Harry Potter model is trained yet. And if we go to performance, you can see that it's still currently training that model. Now, once the model has been trained, we can actually publish the model and start leveraging that particular model. So what I can do is go to the Simpsons and I can select that we're going to publish this. So if I go to the performance, you can see that we've got the data there, and I can select on publish. And the model name will be Simpsons, and the production resource, I'm going to go for Forza production and publish this. I was playing around with the Forza game and trying to do AI on Forza. And I was using it for car detection and so on. So that's basically why that is called Forza. So basically that should be published now, and we should have a prediction URL that we can use to be able to call this as an API. So we've got a couple of ways of being able to call this. If we have an image URL, we're going to call it using that URL there, which is basically specifying a URL. However, if we've got an image file, we're going to call it using the actual image, and it's giving us the URL for that. So hopefully should be able to use everybody's favorite API tool, which is Postman. If you don't have Postman installed, I definitely recommend installing it just for testing APIs and so on. So I should be able to drop on a new tab within Postman. What we're going to be doing is we're going to be making a post request to the actual URL. So I'm going to select the URL there. So copy this, go back to Postman. I should be able to drop this in here. And then I'm going to specify the body, which is going to be binary. And then I'm going to select a file. And what I can do is go down to images. Was it Simpsons, and then the Simpsons data set, and we can choose Chief Wiggum, and I can choose one of the photos of Chief Wiggum there. So that's going to be the actual data, and we need to authenticate. I think if I now send my post request, it's going to be unauthorized because I haven't specified the actual API key. So we do need to specify that. What I'm going to do is to need to specify that the prediction key is going to be this value. Oh, and the content type is going to be application octet stream. I maybe need to make sure that I'm selecting that correctly. I would have thought it would have been an image content type, but they want it to be an octet stream. So let's go to the request headers, if I can find those. Yeah, so we'll drop in that the prediction key is going to be, and then that's going to be this value here. And I want to keep this confidential and not share it on the screen during a live webcast. Let's just see if it's happy with that. Yeah. So you can see here, we're getting the response that we get back if we were calling this as an API. So it's coming back with JSON. It's got Chief Wiggum as the actual most popular, most probable character with 99.3% certainty. And then if you're writing code to do this, it's very easy to go in and to be able to select different values. So what you're doing is you're just attaching something as the actual API body. Let's do another one with Bart and choose that one there and send that. And it's coming back, Homer Simpson it got on the prediction there. So it has actually got one wrong, 62% on Homer Simpson. Again, I only use like 50 images, training images there. So I'm not really using a very large data set there. Okay, I'm going to go back and see how the Harry Potter is doing and see if we've got a trained model there. So performance, yeah. So here it is coming up with 100% again on the score, and I'm very dubious on this because it's only got a few images to actually work with here. So I'm guessing it's not going to be that accurate here, but we can do a quick test. And what I want to do is I can't remember which one of these I used as the actual training images, and we want to use ones that weren't in the actual training set here. So I don't know if I can. How am I going to do this? I'm going to close these tabs. And yeah, if I modify my search for Deathly Hallows, because I think this is the final Harry Potter film, and I think they were a bit older when they were making the Deathly Hallows film here. So I'm guessing if I open this image in a new tab, they will have aged a bit between those photos I've used, because they did look pretty young in those options there. I don't know if I can just remove that. That's probably going to be too large. Let's just try it with that URL and just see what it makes of that. So I'll do a quick test with the URL. And it has picked up, I picked up that as being Ron. Yeah, so it did get that one right here. However, the threshold value is pretty low. I did detect Harry, but oh yeah, it detected him as well. So that wasn't really a great photo to work with. So let's go back and so the search, if I can find that. And let's see if we can find a better one. That one, I don't think we've had that one. So let's open image in new tab. That looks at an appropriate size. I think I actually closed the browser tab, so I'll spin it up again, customvision.ai, Harry Potter, and we'll go into a quick test and just drop in that URL. So here you can see it's picking out loads of these bounding boxes, and in some of these the percentage is quite low. It's detecting stuff over here and stuff down here, but only with a 17% prediction. So what we can do with object detection is we can basically modify this thing, the actual threshold value, and say, well, we only want images where there's a high probability that it is going to be right. So here I'm selecting 71%, and you can see we've got Hermione, we've got Ron, and we've got Harry being detected. So it is able to detect those images correctly. We can also do the same thing with this. We can publish this. So if I go to performance, I should be able to publish this as a URL. So we'll call this Harry Potter. Publish. I didn't choose the actual resource there. And then it's going to be production resource will be Forza prediction, I think, and we'll publish that. So that should now have a prediction URL here. So we can actually specify if we've got an image file, we've got this URL here, and I'm using the same prediction key here. So what I can actually do in Postman is just duplicate this tab, which will give me the same URL, but I can replace the URL for this model with the one that I had in the other model. If I can find it. Did I close that window? find it again. It was this one here, and then it was. I want to show you what the responses are coming back from the actual service. So yeah, I have an image file, so I'm going to use this one because it's going to have the information about the bounding boxes, hopefully, that we're going to be able to see in Postman. So that's going to be the URL. And then in the body, I want to get rid of this and select one of the Harry Potter images. And I'll just choose that one there. Open that one. And we have actually seen this one during the training process, so I'm pretty sure it's going to get this one correct. Let's see what it thinks of that. Here we can see the response coming back here, that we've got Harry identified, we've got Harry identified, and Harry and Harry and Harry. But what we've got here is the actual probability. So a lot of these are a very low probability threshold here. So what we can do is when we get the actual response coming back, we can basically choose what our threshold is going to be, our probability threshold. And we can decide which one of those we're going to use, which one of those is going to be actually usable for those images, depending on which has been given, given the appropriate score. Another thing that we can do is we can actually export the models and use them in on-premise scenarios. So one of the disadvantages of calling this service is that, it's so easy to get up and running with. However, if you're going to be processing video or processing really large volumes of images, processing a video at 50 frames a second could get really, really expensive. So on some of the actual models that we use, it's possible to actually export the model. If I select a compact domain, then there's an option to do an export. I'll see if I can show you how that works. I don't think I have any on the compact domain, but I can create one. Cats dogs. I think I've got one, the option to get one up and running. I'll stick this again on Forza, and what I'm going to use is one of these compact domains. Now these are actually built for using. If I can find them. Yeah, we've got food compact, general compact. And this is basically built for working with either the Vision AI dev kit or for working with basic libraries. So you've got TensorFlow, which is Python based. You've got Core ML, Onyx, and other options that you can export it to. The Vision AI dev kit is really cool. So what this is basically a camera. And you can basically upload your model directly to that particular camera. So if you've got a scenario where you need to have a device that's basically doing, object detection, supposing you've got a baggage conveyor belt and you want to count the number of bags that are going past an airport, you can basically stick one of those over the conveyor belt and it will be able to, trained to recognize, when a bag goes past, and it can send that information back to your cloud service you've got in Azure to be able to, count bags and various things like that. So many industrial scenarios where we can use those options with these exported models. So I'm going to create that project, and then what I'm going to do is to add the images. And I think last time I did promise images of cats and dogs, so let's go for the cats and dogs data set. And in the train cat, I'm not going to take too many, we'll just take a few cats, and those are going to be cat. And we'll do the same with dog. So if I add images and we go to train dog, there's only 33 of those. I want a few more actually. That's better. Those are my dogs. And what I can do is very quickly train this model. Again, it's going to take, because I'm using the quick training, it won't be that accurate, but it will basically allow me to download the model and just basically show you what you get when you do a model download. So I'm just going to hunt around because we did have a scenario, if I can find it. Where I've done logo detection for within Formula One cars, and this was a scenario where using the actual model on premise is going to be a good scenario where we can use this. Okay, so this thing's still training. It should hopefully be ready fairly soon, and we should be able to look at the actual export files that we can create. I was wondering, Erica, if you're listening, if you could just share the YouTube link, because I don't see the questions that are coming up. If we've got any questions popping up here, it would be nice to actually see them.
Yes, absolutely.
Yeah, if you just drop it in chat, and then I can maybe see if there's any popped up there, and answer those, and then
yeah, I can, and then I can put it on the. But you don't see the screen, right?
I'll just put it in private chat, and then I can see it. Yeah, thank you.
Yeah.
Excellent.
We have only one question, I think, so far. So yeah, I guess you are done now with your presentation. So thank you. So yeah, guys, ask your questions if you have any. Mark had asked, do you see the link now?
That's a really good question. Would you take the same approach as supervised learning where you split your data set for training and validation? Absolutely. And what happens internally is they've kind of simplified the process for us with these image sets. So one thing that I've been talking about with machine learning is, you always have your data set and you split it off into the actual data that the model is going to see, and then the data that you're going to use to actually test and validate the images with. And what happens here internally is the service does that for us. If we upload 100 images, it's going to use a certain amount for training, it's going to use a certain amount for testing. The good thing is that makes life easy for us. We don't have to worry about that. The thing that I kind of find that I would like to have a bit more control over is how many images are used for training, how many images, and which images are used for training and validation. When you're using this service, I would recommend keeping a set of images away from the actual service. So keep some on your own PC, and then run your own statistics and do your own validation. Here it's coming up that the model is 100% accurate for everything. I would test those on my own images just to get my own score of what those are. I don't know if we can see this in predictions. No, it's not actually showing those. There is a way using the API where you can actually get the statistics about what it has actually done with the actual models there. And you can actually see the images that it's run and how it's built up those statistics as it went through the actual process using the other images. But it's a really good point. I would definitely test this, using your own images just to give your own score to the model, because it's probably not going to be 100% accurate. And using a larger selection of images, I think if we go back and look at the ones that I was using in the music genres, I think kind of using 540. I was using hundreds of images for those genres. When we look at the performance in that one, you can see that it is much better statistics and much more accurate statistics there when we're using a larger set of images. Okay, so I was going to export the model and show you what options we've got there, and that was on the cats and dogs. So I do have the option, if you go to performance, I've done a quick train and I can click on export. Now this is really nice because we've got the option, if we are using that cool camera, the AI dev kit, we can download it like that. If I'm using ml.net, then we can export an Onyx model. We could drop this down as TensorFlow. It does say Android here. However, TensorFlow, as you know, if you work with it, is basically a Python project. So you could use that within a Python system. It doesn't have to be on an Android operating system. And then if containers is your thing, you can download a Docker file, which you can basically deploy as an Azure function. You can deploy it to Azure IoT Edge, or you can deploy it to Azure Machine Learning. I think TensorFlow is probably the most widely used format that we've got here. So let's export this and see if we can get some files to look at. Unfortunately, I don't have time to code this up, but I have actually built systems using these exported models here, and I'll just show you what you get for your money when you download one of those things. So looking in here, we've got the actual model.pb. So this is the actual model file itself. We've got the properties on the model, we've got the license, and we've got a text document. So it's giving us the actual model in a PB format for TensorFlow. I'm going to try one of the other options actually, because I was hoping to get a bit of Python to run. So this is going to be for ml.net in the Onyx format. And here we get the model in the Onyx format and the various options there. I've seen these previously giving us some source code to actually run with these. So I don't know if they will do in this one here. I'll try Dockerfile and see what that gives us. Go for Windows. Yeah, so we've got a bit more stuff here. We've got our model there, and yeah, it's got the oh yeah, Python source file. So here we've got an actual Python code that's able to actually run this and score the actual model. So I'll just bring that up in Studio. So what you can see here is the actual Python code that we're going to be using to actually run the model there. So dropping that into an Azure function allows you to just basically run that. You can see there's not that much code in there. Fairly simple implementation, but that can be dropped in a Docker container in various different hosting environments to be able to give us the actual model that we can run either as an Azure function. And when it's running an Azure function, you get like 1 million function executions per month for free. So that's going to be a lot less expensive than using the actual cog. The actual custom vision service. You could also run it on your own device if you did want to run it on a mobile device there. Okay, so I think I'm about done with the presentations, and hopefully it's been a nice walkthrough on using the custom vision service. There are some basic tutorials if you do need to actually walk through, but my recommendation would be just jump in there, get some images, play around with some images, you create your own data sets. I do this as you've seen me doing in Google. You just search for, say, if you want to do classification with different dog breeds, you can just go in Poodle, and you get thousands of images of Poodle here. And you can actually save down the web page. So if I drop those as images and just save that there. And what we're going to get when we do that export there is, if I can find it, if I go to images, when that's downloaded, you get all of these images here. So what I can do is just delete these. I've got a webcast on this on my YouTube channel about creating data sets, and some of these are not image files, so these ones here are not going to be part of those. But if I then do command, and I grew up using DOS. I'm that old, so I remember that you can rename files star.jpg. Now we've got 214 images of poodles, and that's a nice number to be able to stick into the custom vision service. You want to have a couple of hundred at least, and then you could do that with, say, 4 or 5 different dog breeds, and see if you can identify the difference between those. It's a nice exercise to be able to run through. You can also take the available data sets if you go to kaggle.com. Sorry. What Kaggle will have is basic data sets that you can download. So if you basically search for Simpsons, you've got the Simpsons character data set that I was using, and there's various other images that you can search for. There's all kinds of scenarios there and data sets that are easy to work with using that the custom vision service. And they're all free to download. You do need to register with the site, but they are free to download. And these are really large data sets. You can see there's 1 gigabyte of Simpsons character data data set that to get you started. Okay, I think I'm about done with that. Is there any more questions that we can take before I sign off?
No, there is no more questions right now. So yeah, I want to thank you for another evening with us. Thank you so much for being such a key part of AI Tuesdays and this whole series. Before you sign off, I just want to quickly mention about next week. Guys, you've been following Ellen here for quite some time now with quite some sessions. And next week, I actually have a Reactor community Spotlight event, as we call it, where I will be interviewing Alan, Peter, and Chris, two of his colleagues, as well as Alan. And then we will be talking about community and love for technology and the passion and everything that they do for the community. So make sure you sign up and then join us. It's going to be during lunchtime here in Stockholm, so Swedish time. I dropped in the chat the link where you can sign up, and yeah, it's going to be an easy listen during lunch next Tuesday. Yeah, apart from that, let's add you back to yes. And and next week we have the last episode of this series for the beginner content, where we are going to be talking about what is it again? Do you think AI is heavy or machine? What's it called? Wait, let me just have a quick look. It's a long one actually. It's called think machine learning is hard. Let AI do the heavy lifting. That's the one. So thank you so much, guys, for being with us today again. And Alan, thank you so much for being here. I wish you a good evening. Thank you.
Great, thanks for that.